Welcome back to Balbikan Bharti. As you know, we are progressed in matrix, and there we are discussing how to find the inverse of a matrix. So there are two methods of finding the inverse of a matrix. The first method that I have described is determinant method. There we have find how to get the inverse of matrix by the formula of adjoint of matrix A and divided by the determinant of A. So this is the formula, and I have already shown you by giving an example of any particular matrix. But one thing I have to add is that value of determinant must not be equal to 0, because something divided by 0 is undefined. So the value of the determinant, that is taking a crucial part in this. So first you have to check whether this value is coming 0. So then there is no point of finding inverse. This is not possible. So this is one thing. So, and also I have said, if two matrix are coming as unit matrix or in identity matrix, so any of this could be the inverse of the other one. So A into B, if it is unit matrix, so A could be the inverse of B, or B could be the inverse of A. That is also done. So the next one is the method of element or elementary. Anything you can say is a elementary method. So that also can be said. So this says I will use the rule that I have explained, that any matrix is also true if I multiply with the identity matrix. So this, the value does not change. So identity matrix, if I multiply in any way you write, if you this is following with the identity matrix, it is following the commutative law, because if we multiply A cross I or I cross A, if we do so, you will get the same value identity matrix. And moreover, we are working with a non-singular matrix, because this has to be said that if the matrix is only carrying one element, so this is a non-singular, this is singular matrix, and we will work with non-singular matrix. So with one element I cannot do all such operations. So for doing operation, we must have a non-singular matrix. This is one condition. Another condition, where we are taking the matrix is a square matrix. Okay, so the whatever I am showing, that has to be a square matrix. Okay, so this is possible, and the order of the unit matrix and this matrix has to be same. Then only I can get. When we do product, so the number of column in the identity matrix has to be the same with the number of rows in the matrix. So then only I can. This is the rule of the multiplication, where number of column in the first matrix has to be same in the number of rows of the second matrix. Okay. So with that concept, and carrying the same concept here also, I will now calculate the elementary by the elementary method, how to find the inverse of that. So now to do that, rule is that I will go with this relation, where any matrix if I say is a relation, if I multiply with the identity matrix, I will get the. So during the process, my target has to change this into identity matrix, and for that I do operation. That operation means the matrix can have addition, subtraction, and multiplication, and these three operations I will do to the rows, or either rows or columns. But you cannot mix the operation in a process by doing it both. So either you have to follow the rows operation, whatever operation you do, you have to do in the rows, if you following the rows operation, or if you from the starting you are doing the column operation, you have to stick with the column operation. You cannot mix one time column, one time row, or mix and match all that. So that cannot be done. For this kind of thing, the rule is operation must be an individual operation, either in rows or column. So that means if you start with the column operation, you have to end with the column operation. If you start with the rows operation, you have to end with the rows operation. You cannot mix and match. First thing is that, and second thing, whatever operation you do here, you have to do with this identity matrix. So in the process, this will turn into identity matrix, and this will turn in some other matrix. Okay. So while I doing that, if I do that, it is become identity matrix and it is become another matrix. Let's say this turned into B matrix. Then as you can see that this is become this equation. So that means this is inverse of this. You can prove. So whatever I will find, this will be the inverse of that. This is my intention of doing that. So the process will go this way. So let us start with an example that I have taken this earlier also. So the matrix I will take is this one that I have already working with 3 1 3 1 2 minus 2, and during the process I can say the operation is of your choice. You can do anything to bring it into the identity matrix form. So this is not having any fixed kind of rule. That rule you have to make your own. Whatever operation you will do, thing is that the standing rule, standing instruction is that you have to do operation with A and I both together. You cannot mix rows and column operation together. This is the only rule, and apart from this, everything is your choice. So if I write it, so while I will do operation to this two, this will remain as same. So this will carry as it is. So I will write it in form of A only. So this I am writing. This needs much practice, because this I cannot tell you how to do it perfectly and what is the perfect way of doing. You have to practice more to be the master of this. So this is basically very you can say cumbersome process also, and that at the same time you need to use your brain to get get mastery on this subject, how to convert this into identity matrix. So while I am doing, you can understand how much patience or tolerance is needed to do that. So the first operation that I will do, I have already computed, that's why I will go with that. The first operation, that row 1 will be converted by taking R1 minus R2. This is my first operation. Okay, I have just done it, so that's why I am just following the rule, because that was very much patience-full job. Okay, so what I do, this is termed as row 1, this is row 2, you know it, and similarly this is row 1, row 2 and row 3. So whatever operation I will do here, I have to continue there, then only the thing will go right. So row 1 is this one, I am deducting R2, row 2. So this will be placed in row 1. So this is very significant. You have to write it like that. Whatever operation doing, row 1 will become by deducting row 1 to row 2. So then this will turn into what? This 3 minus 2, row 1 minus row 2 will become 1. This minus this becomes 0. This minus this become 4. So the remaining thing will be as it is. Okay, so 0 1 1. So I have finished the left hand side. The same operation I have to do here. So this will become row 1 minus row 2 is will be 1. This minus this is equal to minus 1. This minus is equal to 0. So this will be 0. So whatever is happening this side is not a headache for me. Headache is this side. You have to turn it into identity matrix. This is my target. So this is A. Okay. In next operation, what I do, I will take R2 become R2 by 2. So what I am doing, the next operation, just R2 will become, I'll do R2 by 2. This will be my operation. So this is my ultimate. Now this will turn, when I'll do R2 by 2, this will become 1. R2 by 2, this will become half. R2 by 2, this will become 1. So this will be the changes. The same thing I'll do. R2 by 2, that means is equal to 0. R2 by 2, this will become half, and this will become 0. So this is the operation, the second operation. Third operation that I did, R2 is equal to R2 plus, R2 is equal to R2 plus, what I did, R1 by 4. What I am doing, R1 by 4. So with this I am doing. So you just see with me, R2 become this will, there the change will come. R2, this whatever it is there, with that what I am adding, R1 by 4. So R1 by 4, that means 1 by 4 is added to this. So this will become 5 by 4. If I multiply anything with 0, that won't change. So R2 here it will be same, and R1 by 4, if I do, this will become 1. I am adding to this, so 1 minus 1, that will become 0. Okay. So this is my third operation. Fourth operation, what I am doing, R1 by 4. So R1 become, I have to do the same thing here. So this R2 will be added to with R1 by 4. R1 by 4 is equal to 1 by 4. So this will become 1 by 4. This is multiplied with 1 by 4, that is 1 by 4 and half. This will become minus 1 by 4 plus half will become how much? 1 by 4 then. Okay, because 1 by 4, there is 1 by 2 is there. So this is 1 by 4 minus plus half. What would become? This is equal to 4. This is minus 1 plus 2. This is 1 by 4. Okay, so this become 1 by 4, and what else? 0 with 1 by 4 won't change anything. So this will be same. The next operation is R1 become R1 by 4. So what I am doing, this I am dividing with 4. So R1 become R1 by 4. So this become 1 then, and this become 1 by 4 then, and 0 does not will change. So the same operation I will do, 1 by 4 then, this is 1 by 4, this won't change. Okay, the next operation that I will do, R2 become R2 minus 5R1. So the next one, R2 become R2 minus 5R1, isn't it? R2 minus 5R1 I am doing. Let's see what would happen there. R2, I am converting this into, this will be same, and I am deducting with 5R1. So 5R1 will be 5 by 4R1. Now if I minus it, it will become 0. I multiply with 5, it won't change, so this will become same. I multiply with minus 5, and R2 minus 5, this will become minus 5. Because I multiply with minus 5, R2 was 0, so this will turn into this. So this will be changed. The same thing I will do here. R2 become R2 minus 5R1, so this will become 1 by 4 minus 5 by 4, that's equal to minus 1. So this will become minus 1. This is minus 5 by 4 plus minus 5 by 4. This will be passed because I am deducting. The same thing I did here, no? This was how much? This was earlier minus 1, what I did, R2 was 1 minus 5 by 4 I deducted. This is minus become, yes, that was right. And this is become R2 was R2 was this is 1 by 4 R2 plus sorry, what I did R2 minus of 5 of R1 means minus 1 by 4. So this become plus, so 5 by 4, this become 6 by 4. Okay, 6 by 4, and there it is multiplying and minus, so this will not change. Okay, so then next operation is my, what I am doing, R1 is equal to 5R1 plus R2. So R1 become 5R1 plus R2 I am doing with this. So what would change here? 5R1 means 5 by 4 R1. This is changing to R2. So R2 will be as it is being added. So this will become 5 by R1. If I multiply with 5 there, it won't change. This is 5 I am multiplying with R1. So 5R1. So I am adding this. So this R2, this will become half. This will become 0. And this will be the change. Isn't it? So I am doing 5R1. So this will be the change in this. Isn't it? The same operation I will do. Let me take the term here. What I am doing 5R1. So this is 5 by 4. I am adding to this one. So this will be 5 by 4 minus 1 by 4. So this will become same. Now I am multiplying with 5 by 4. I am adding to this 6 by 4. So this will be 1 by 4. And this will be plus there 1 by 4. And this I am multiplying. This will not change. Okay. So this is the change here with this one. Then my next operation is R2 is equal to R2 plus 5R3. R2 is equal to R2 plus 5R3. This I am doing with R2 plus 5R3 I am doing. So what changes it will do? R2 will be changed. So R2 along with that 5R1 I multiply. So 0 will not change. This is R2 plus 5R1. That means the change is 5 plus R2. So that means equal to 11 by 2. So this will change into 11 by 2. This 5 I am multiplying here. I am adding to this. So this will become 0. Okay. So same thing I will do here. The first operation, R2 will be added to 5R1. So 0. So this will not change. This is 5 multiplying. This also will not change. 5. If I multiply here and add to R2, so this will become, this is not changing, this will become 5. Fine. Okay. So next operation is R2 I am multiplying with 2. So this I am multiplying with 2. So R2 become 2R2. Okay. So if I do it, this will become 5 by 2. This will become 1 and this is 0. The same thing I will do here. 2, 2 and 0. Okay. My next step is R1. Oh sorry, what I have changed here, I am not supposed to change it. R2 I am changing, sorry. So this will become half. I would not change this, sorry. What I am changing, R2 is equal to 2R1. So there I am changing. So this will become 0. This will become 1. This will 0. So this is multiplied by 2. This will become 6 by 2. That means equal to 3. And this I am multiplying with 2. That means it will become 10. So this will be the change. The next operation is R1 into 2. R1 also I am multiplying with 2. Okay. 2R1. So what would change? This time this will change. This will become 1. So same thing I will change here. I will change here. So that operation you can do in one shot also. Doing R1 is equal to 2R1 and R2 is equal to 2. You can write it and you can do it. You need not to follow the second step. Okay. The first in one step also you can do. So that is flexibility is there. But we are not changing column to row. All operation we are doing with rows only. So the next is R1 is equal to R1 minus R2. The next operation is R1 become R1 minus R2 I am doing. So I am deducting R1, changing this and deducting R2 from this. So this will be same. This will change into 0. This will be same. So what I am doing, this minus this half minus of minus and plus 2, this will be 5 by 2. So this will become your 5 by 2. This is half minus 3, that means equal to minus 5 by 2. Okay, isn't it? So this will become minus 5 by 2, and this 0 minus 10, that means equal to minus 10. This will be this one. Okay, so now the next operation is R1 by R1 into 2 by 5. So R1 is transfer into, I am multiplying it 2 by 5 to make it 1. So this will become 1. So you can see the things has changed into, no, still it is there. 1 by 1 operation, this must be gone somewhere. While I am doing this, the next operation is multiplied. No, in between something I did, so I have to follow one more step. Okay, fine. So in between I must have done something. Okay, anyhow I will do it. So this is one still. So anyhow, so this is done. So what I do, 2 by 5 I am multiplying. So the same operation will be carried here. So this is 2 by 5. This is changed into this. This is 1. This is minus 1. 2 by 5 means 2. That means 4. And this will become 4. So 10 into 2 by 5, that is equal to 4. Minus is there. So this is the change. Now remaining this one. So for this I can deduct this from this. So 0 by 0 is equal to 0. This will be 0. So another operation, R3 has to be become R3 minus R2 if I deduct. If I do that operation, so this will become R3 minus R2 if I do. So this will become 0. And remaining will be same. So now it has converted into unitary. Now the same operation I will do here. R3 become R3 minus R2. So this will become 2. This will become minus 3. And this will become 1 minus 10, that is equal to minus 9. 1 minus 10 I am doing. So this is ultimate. So this has transferred into a unitary matrix. So this is I. This is some matrix. Let's say I am talking, this is B into A. So now when this relation satisfied, B into A is equal to a unit matrix. So this will be the inverse of this matrix. So we can say by this elementary method I have found A inverse, that is equal to 1 minus 4 minus 2 3 10, and this is 2 minus 3 minus 9. So this is my inverse matrix. Okay, so this is the second method of doing the inverse. Okay, so just in the next class I will take another such example to give it more clarity, and that after doing that I will keep the result and I will compare with this method whether the results are coming the same or not. Okay, so that will be my target there. Okay, so fine. Okay, thank you for now.